Okay, na?
Yes, sir.
So to find the work done by any variable forces, like say F is equals to 10x, like what F is equals to 10 plus of your 2y, without using calculation and integration, we can do these problems better. What you do is right now for this one, the basic trick I'm telling you, see whenever we get such type of equations, wherever you see, just put the values of the given and find the forces of your F1 and F2. So I mean to say just find out the average, like F1 plus of your F2 divided by 2. Okay, put the values given and find the forces of your F1 and F2 beta and take the values of your F1 plus F2 divided by 2. Okay, then work done will be equal to your F1 plus of your F2 divided by 2 into your delta R J. Delta R is nothing but displacement. Displacement is nothing but R2 minus R1. You will directly get the answer for such type of your questions. Whenever you are getting the forces,
Yes,
like
sir.
F is equals to 10x or F is equals to 10 plus 2y, and if he's asking us to calculate the work done, just find the value of F1, find the value of F2, and take the average of that one and multiply by the displacement. Okay. Let's say I'll give you one example.
Yes,
Sir,
sir.
here question. F is equals to like 20 plus of your 10y. Isn't it? It's acting on a particle, like say, for example, in y direction. Some example. Okay. Now, if I need to calculate the work done to displace it, work done to displace the y-axis lecture, I'll take the positions also from y-axis only. Like y is equals to 0 to y is equals to 1 meter. General ga పిల్లలు ఏం చేస్తారంటే ఇది ఇంటిగ్రేషన్ చేసుకుంటూ వెళ్ళిపోతారు. That will be a time consuming. Now what you do is just put y is equals to 0. So we'll get the value of f1 and the sum. Y 0 పెట్టుకో, f1 is equals to 20 Newton. Then keep y is equals to 1 because it is given in the problem. So we'll get the value of f2. F2 value will be equal to how much beta? 20 plus 10. That will be equal to 30 Newton. Then what will be the displacement? Delta R. Delta R will be equal to your y2 minus y1. That is 1 minus 0. That will be equal to 1 meter. So what do you calculate the work done? Work done is equals to your f1 plus f2 divided by 2 into your delta R. Got it? F1 plus F2 is 20
Yes,
plus 30 divided by 2 into your 1. That is nothing but 50 divided by 2. That will be equal to 25 joules. Got it?
Yes, sir.
లేకపోతే జనరల్ గా మనం ఏం చేస్తామంటే with the general method what we do is right now by lengthy method work done is equals to integration వేసుకుంటాం. Other method if I'm taking right now, other method W is equals to F into dr రాసుకుంటాము. Then we'll try to take the limits from 0 to 1. So that is equals to integral 20 plus of your 10 into y into your dy. Will write right now here again from 0 to your 1, isn't it? So then we'll go on to the integration for, let's say it is your 20 out, it is your dy 0 to your 1 plus of your distance is 10 out, integral of y into your dy, limit are 0 to 1. So again it will be coming for me 20 into y plus integral of y into dy is nothing but y square. So it is 10 into y square divided by 2. Limits will be from 0 to your 1. So that will be equal to how much will be 20 into y plus this one is 5 into y square. Substitute the limits from 0 to 1. We'll get the answer. From substituting upper limit minus lower limit. So this value will become how much will be better? 25 minus 0. So that will be 25 joules. Got an idea?
Yes, sir.
Okay, now? So
Yes, sir.
whenever you get this type of equations like f is equals 10x, x plus 10y. So what I'm doing is right now, just find out the value of f1 and f2, take the average and take the displacement and use the formula W is equals to your f1 plus f2 into your divided by 2 into your delta. That will directly give me the answer. Got it?
Yes, sir.
Sure. As you, this is also one more small way to do the problems, like say differential integral relations on AMCO right now. Stop both on the just in fact. Yeah. Okay. For problems on many variables. This is also one of the favorite area for the JEE mains beta, like x comma y comma z equations is that. What you do is directly apply the differential equation formula. That is your differential integral relation. Differentiation of x comma y is equals to y into your dx plus of your x into your dx. That is differential of your xy. Once y is kept constant, then x is kept constant, and try to simplify the problem. Avuna? Like, for
Yes, sir.
example, differentiation of your x square comma y square. So what I'll do right now, I'll keep x square constant. So it is 2y into your dy plus next one is y square constant. Then it is your 2x into your dx. So I'm just what I'm doing, first keeping x square to be constant and y square is differentiated. Then again, y square is been kept constant right now for me, isn't it? Then I'm differentiating your x square. We'll get the answer for that one. Okay, na?
Yes, sir.
Like say, for example, I'll give you one question for it. Like, ఇది కూడా ఒకసారి అడిగిన question J means la. F is equals to y into your I cap plus x into your j cap అన్నాను. Isn't it? And it is acting on a body, like say from 0 to your 2 meter, 2 meter. Okay. Force is given how much for me? Y cap plus xyj cap. And it is acting on a body to displace the body from where? Beta 0, 0 to your 2 meter to your 2 meter. Then is asking is work done by this force is how much? Work done by this force. Work done by this force is equals to how much? Just use what the trick what I told you right now, differential integral trick. That is work done will be equal to integral of your y into your dx plus of your x into your dy. Limits are 0, 0 to your 2, 2. Okay, like say this one is integral of your differential of your x into your y. This is 0, 0 and this one is 2, 2. Ante kada?
Yes, sir.
So that will be equal to how much for me? X into y differential. So it is 0, 0, 2, 2. So what will be the answer? 2 into 2 minus 0. So that will be equal to 4 joules. అంతే కదా?
Yes, sir.
ఇప్పుడు ఈ మెథడ్ రాకపోతే ఏం చేయాలంటే నువ్వు మళ్ళా జనరల్ మెథడ్ ఎలా పోతుందంటే యూ నీడ్ టు ఇంటిగ్రేట్ ఇండివిజువల్ టర్మ్స్ అండ్ ట్రై టు డూ ద ప్రాబ్లమ్. Sorry, what I'm doing is whenever there are the problems which involves a larger variables like x, y, and z, you directly use the relation differential of your x comma y is equals to y into your dx plus of your x into dx. What I'm doing is I'm keeping first x square is being kept constant and y square is differentiated. Then again y square is being kept constant in this one. Again x square is differentiated. What an idea?
Yes, sir.
Isn't it? We will get the answer for such type of equations easily. Clear?
Yes, sir.
Now tell me the answer for this one. Just let me see how far you can do it out. Like say if I give you the force, F bar is equals to 3x square into your y square into z square into your I cap plus of your 2 into your x cube into y into your z square into your j cap plus of your 2 into your x square y square z into your k cap. Isn't it? And the body is being displaced by, the body displaces from like 0, 0, 0 to 2 meter, 2 meter, 2 meter. Okay, so my work done is how much? The work done is dash. Work done is dash. See the question once again. F is given as now, it is a variable of x, y, and z. So I can write the first force right now here. F1 will be equal to your 3 into your x square into your, this is your 3 into your x square, this is y square into z square plus of your, this one is your x cube into your 2y into your z square. Can I write like this? Plus of your,
Yes,
this
sir.
one is your x cube, this one is x square, y square, z into your k. So it is nothing but of your x cube into your y square into 2 times of your z. Isn't it? That means it is differential of what right now for me? Differential of your x cube comma y square z square. Antena? Clear?
Yes, sir.
Now calculate the work done. So work done is equals to integral of your differentiation of your x cube y square z square. Limits are 0, 0, 0 to your 2, 2, 2. So that will come out for me how much better. First keep this one constant. So it will be equal to your x cube y square z square. And limits will be equal to your 0, 0, 0. And this one is 2, 2, 2. That means that will become for me how much? 2 cube into your 2 square into your 2 square. minus completely 0. So that will be equal to how much? 128. That's it. Okay. I'm just
Yes,
using the
sir.
differential equation basically. Listen, without going in much integration particulation, we just use the differential equation integral relations and try to simplify the problem. That will be more easy to travel or to do such type of a problems. This is the one area where the problems will be asked. And another very important area is nothing but equilibrium of the bodies. Equilibrium of bodies. This is also one of the important area to do the problems. Equilibriums of your bodies. Like say we have neutral equilibrium, stable equilibrium conditions when you will be giving the force. So force general F is equals to minus of potential gradient du by your dr is known as of what beta? Force. Negative potential gradient is known as what? Force. U is your potential energy and r is nothing but what for me? Position vector. Antena?
Yes, sir.
Like say to decide whether the equilibrium is stable or unstable or neutral, what you will do is right now we'll be writing F is equals to minus of your du by your, if it is an x-axis, dx must be equal to 0. What you do is do the double differentiation. If d square u by your dx square is coming out to be a positive, then it will represent me what? A stable equilibrium. That means potential energy is minimum. Clear? Already అడిగాడు మెయిన్స్ లో అడ్వాన్స్ థింకింగ్ పైన రెగ్యులర్ క్వశ్చన్స్ అడుగుతుంటాడు. అదే విధంగా సెకండ్ క్వశ్చన్ F is equals to minus of your du by your dx is equals to 0, and in the same way here if d square u by your dx square is coming out for me negative, then equilibrium will be what type of equilibrium beta? Is unstable equilibrium. Clear?
Yes, sir.
So for stable equilibrium condition in God, for stable equilibrium, the condition is, what is the condition? Stable equilibrium key, first you equate minus of du by dx is equal to 0, then do the double differentiation. If the answer comes out to be positive, it will be stable. If the double differentiation is coming out to be negative, that will be equal to your unstable. Okay? In the same way, F is equals to again minus of your du by your dx is equals to 0. If I am writing here d square u by your dx square is coming out to be 0, in that case the equilibrium will be your neutral equilibrium. Got it?
Yes, sir.
Got an idea? Sure. Let's say for example, I'll give you a question. Like potential energy is given as a function of x as of your u naught by 2 into your x by your a whole square. As a particle is moving along x-axis under the force of this much with its potential energy, u is equals to u naught by 2 into x by your a whole square, where a and u naught are constant beta. So now question is the force acting on particle is how much? The force acting on particle. The force acting on particle at x is equals to 0 is how much? Can I do it? U is given as a function of x.
Yes, sir.
So first what we need to do, calculate the value of f. F is equals to minus of du by your dx. It doesn't do du by dx. Minus of your u naught, differentiation of your x by a. A is also your constant right now for me. So a square constant అయిపోతుంది. Differentiation of your x square is nothing but 2x. ఈ 2 వెళ్ళిపోతుంది. So this will be equal to x. అంతే కదా? Now put x is equals to 0. So what will get f is equals to 0. Antena?
Yes, sir.
So that's an answer. So what is the force acting on the particle? Means f is equals to your 0. That's it. Done?
Yes, sir.
So let me take you one more question. With the J means question. Like say he has given me the potential energy as a function of x as equal to your a by x power of your 12 minus b by x power of your 6, where a and b are constants beta here and x is nothing but of a distance between anything basically. What is asking is what should be the value of x for the equilibrium? What should be the value of x? The value of x for equilibrium. Okay, some options are given. Potential energy is given as a function of x beta, where a and b are right now for me constant. So what is the first step you will try to do beta? First calculate the force. F is equals to minus of your du by your dx calculate చేస్తాం, isn't it? So u as a function of your x ఇచ్చాడు, that is nothing but of your a x by your 12 minus b x power of your 6. So du by dx ఎంత వస్తుంది? So it is du by your dx will be equal to, first one is right now minus 12 into your a divided by x power 13. అంతేనా? Next one is minus minus plus, this is nothing but 6 into b divided by x power 7. And this must be equal to how much for me? 0. Ante minus of 12 into your a x power of your 13 must be equal to your minus of your 6b divided by x power of your 7. Antena? So this is 6 ones are e minus వెళ్ళిపోతుంది, 6 ones are 6 2s are 12, x power 7. Here it will be your x power 6. So it is 2a divided by x power 6 is equals to your b. So what is the value of x? X power 6 will be equal to your 2a divided by your b. That means x will be equal to your 2a by your b to the power of your 1 by 6. So this will be the answer for this. Got it?
Yes, sir.
Isn't it? So I hope you got one basic idea how to do the problems when forces are being given, and as well as if your u is also given for you. It is one of the important area. Okay, means lo 2 సార్లు అడిగాడు ఇటువంటి మోడల్స్ బేసికల్ గా నీకు.
Yes, sir.
వర్క్ ఎనర్జీ థియరం గుర్తుందా? What is the work energy
Yes,
theorem?
sir. Sum of all energy is 0.
Yeah, very good. Work energy theorem. So what is the work energy theorem? Work done must be equal to your work done by all the forces must be equal to change in kinetic energy. So what is the work done? Work done can be your, it may be your non-conservative forces plus it is also your conservative forces. Both it can be. Okay.
Yes, sir.
In case of non-conservative forces means what beta? Conservative, non-conservative forces means like friction. These are all of them are non-conservative force. So in that case, how do you write the work done? Work done will always be equal to your final energy minus initial energy. That means final mechanical energy, I can say. E is nothing but of your my final mechanical energy. That means work done will be equal to your final mechanical energy means K2 plus of your U2 minus initial mechanical energy. That is nothing but of your K1 plus of your U1. Okay, in terms of your non-conservative forces we are writing, work done will be equal to your final kinetic energy minus initial kinetic energy. Clear?
Yes, sir.
That means like work done will be equal to your E2 minus of E1 Rashinapur. I can write this one. From this one I can write delta U plus of your delta K for any particle. Isn't it? In non-conservative forces, whenever you're doing the problems, you can directly use this method to do the numericals and solve the problems related to this one. Okay?
Yes, sir.
Now tell me, what is the energy stored by the springs beta? Potential energy stored by the spring. U is equals to half into K into your x square. Different forms in which I can write this one beta. F is equals to your K into your x. F is equals to K into your x part of relation. So now I can write here U is also equal to your half into K value. I can write as of your how much beta? F by your x into your x square. So this one will get cancelled. This is also equal to your how much for mu? F into your x. Last question. Or else
Yes,
you
sir.
can also be written as of your half into your K into your x value. From this one I can write as of your F square divided by K square. This one will get cancelled. So U is equals to half into your F square divided by K. I can even write like this. Done?
Yes, sir.
ఇంకే టాపిక్స్ రివైజ్ చేస్తున్నావు నువ్వు?
Sir, semiconductors, modern physics.
సెమీకండక్టర్స్ ట్రాన్సిస్టర్స్ యాజ్ అన్ యాంప్లిఫైయర్ గుర్తుందా? ఒకసారి రివైజ్ చేయను నేను తొందరగా.
Okay, sir.
ట్రాన్సిస్టర్స్ యాజ్ ఏ రెసిస్టర్స్ పార్ట్ ఆఫ్
Yes,
రిలేషన్, జీనా డయోడ్ పార్ట్ ఆఫ్ రిలేషన్, దానిపైన స్ట్రక్ అవుతుంది. picture. Transistor circuit problems chapter. Like say for example, transistor as a switch. Very important area for JEE Mains. Transistor as a switch. Transistor is good. It is a 3-terminal device which has right now for me emitter. In middle there is a base, and this one is nothing but of your collector. Emitter is highly added with impurity. Impurity is very high. Collector is moderate, and base is very, very small. Size level with the size la capacitor. Collector is very bigger in size than the emitter, then the base. Base is very, very thin. In size, I can say that collector is greater than emitter. Emitter is greater than of your base. In terms of impurity, which is having more impurity, beta? Emitter is having more impurity compared to the collector, and collector is having more impurity compared to your base.
Yes, sir.
Now I'm trying to talk about transistor as a switch and amplifier. Amplifier this one is, say for example, a transistor like this. Okay, this is your N, this is your P, and this is your N. So arrow mark will be always from the P to your N part affiliation. This is your base, and this is your emitter, and this is your collector. Okay?
Yes, sir.
Chalo. And you know that the switching connection, emitter and base and emitter should always be in forward biased. Hona?
Yes, sir.
Collector and emitter should always be in your reverse bias. This is a basic condition. That means between these two, it should be your forward biased. These two should be your reverse biased. And this is right now having some resistance here right now. This is your base resistance. And here P should be connected to the positive terminal, and this should be connected to the negative terminal. And this one is represented by your VBB. Clear? Is it clear, beta?
Yes, sir.
Good. Forward bias at a connection at emitter and base should always be having your forward bias. And whatever the forward bias is there, P should be connected to a positive terminal, and this should be connected to your negative terminal. And then,
yes.
Chalo.
Yes, sir.
This one is connected to your right now output. That is nothing but of your load resistance, RL. So output is being right now connected to your collector part affiliation. And this should be what bias beta? Reverse bias. That means this N should be connected to positive terminal, and this should be connected to your negative terminal. And this potential is your right now VCC. Clear? The potential across this one will be equal to your V base and emitter, and the potential across this one will be equal to your potential across your collector and as well as of your emitter. Okay? As an amplifier, if I'm taking, if this is your input, the output is something like this, highly magnified, like this. So input resistance should none. There is a flow of current right now from here right now. This is a positive terminal. This is a negative terminal right now. So current which has been passing from this one is nothing but of your base current. So if I'm talking about for your input sector, if I'm applying the Ohm's law, VI will be equal to your delta VBE, input potential resistance. Potential is represented by your base and emitter. That means from Ohm's law, I can represent this one as well, beta. BE will be equal to your base current into your input resistance. Ante kada? V is equals to I into your R.
Yes, sir.
Right?
बारिश पड़ रही थी बारिश पड़ रही थी
For output circuit, beta. This is your output circuit. Apply KVL for this one. Go like this. From here, I'm applying the KVL. Isn't it? Now, see if I'm writing the KVL for this one. For output section, apply the KVL. I'm going from here. So it will be your VCC. సేమ్ డైరెక్షన్ లో పోతాం కాబట్టి మైనస్ దిస్ విల్ బి యువర్ కరెంట్ ఐసి ఇంటూ యువర్ ఆర్ఎల్ అంతే కదా దీనిలో కరెంట్ ఎట్లా ఉంది రైట్ నౌ సో దిస్ ఇస్ ద ఫ్లో ఆఫ్ యువర్ కరెంట్ రైట్ నౌ పాజిటివ్ టెర్మినల్ సో వాట్ ఎవర్ ద కరెంట్ ఈస్ బీన్ ఫ్లోయింగ్ దిస్ విల్ బి ఈక్వల్ టు యువర్ ఐసి హియర్ రైట్ సో VCC minus IC into your RL minus again you're coming to this one here the potential will be equal to your VCE that will be equal to your 0 okay na KVL starting
Yes,
from here
sir.
VCC the same direction I'm moving so it is your IC into your RL then the potential across this one is nothing but of your VCE collector and emitter and that must be equal to 0 that means I can write from this one VCE will be equal to your VCC minus of your IC into your RL. Okay. See, this
Yes,
output
sir.
cannot be changed, beta. The output cannot be changed. And a change in VCC will always be equal to 0. And change in your VBB also will also be equal to 0. In the input current, input potential and output potential are constant. So very small changes in the collector current will always be 0 and very small changes in the base current, base potential will always be equal to 0. And if I'm writing this one in terms of a change, like say this one, delta VCE will be equal to your delta VCC minus delta IC into your RL. And this is 0. And delta VCE output potential will be equal to minus of your IC into your RL. అంతే కదా
Yes, sir.
డెల్టా ఐసి ఇంటూ ఆర్ఎల్ క్లియర్ ఇన్పుట్ కేమో బేస్ కరెంట్ ఇంటూ ఇన్పుట్ రెసిస్టెన్స్ అవుట్పుట్ కేమో కలెక్టర్ కరెంట్ ఇంటూ యువర్ లోడ్ రెసిస్టెన్స్ ఓకే
Sir.
చలో ట్రాన్సిస్టర్లో నీకు రిలేషన్ తెలుసు కదా బేస్ కరెంట్ విల్ బి ఈక్వల్ టు యువర్ సారీ ఎమిటర్ కరెంట్ విల్ బి ఈక్వల్ టు యువర్ బేస్ కరెంట్ ప్లస్ ఆఫ్ యువర్ కలెక్టర్ కరెంట్ అవునా divided by your IC, divided by your IC and divided by your IC. IE by IC is nothing but what beta? 1 by alpha and IB by IC will be equal to 1 by beta. IC by IC is nothing but 1. So that means 1 by alpha will be equal to how much for me beta? 1 by alpha will be equal to your, if I take the LCM for this one, beta 1 plus of your beta. That means alpha value will be equal to beta divided by 1 plus beta. What is alpha and beta beta? Current gains for the common emitter and common base. Okay na?
Yes, sir.
Common emitter ki aithe beta తో రిప్రజెంట్ చేస్తాము కామన్ బేస్ కి అయితే ఎలా రిప్రజెంట్ చేస్తాం ఆల్ఫా తో రిప్రజెంట్ చేస్తాం when you are using common emitter transistor that is represented by beta అంటే beta అంటే ఎలా రాస్తాం నాన్న beta will be equal to your collector current divided by base current. Alpha and ఎలా రాస్తాం నాన్న alpha is equals to your collector current that is output current divided by input current. Emitter will base will be common at a time కాబట్టి basic formulas అవునా సో alpha value వచ్చేసిందా in the same way from this one beta value కనుకో అది ఆల్రెడీ ఒకసారి అడిగాడు నాన్న దీనిపైన చాలా క్వశ్చన్స్ alpha and beta పైన. So from this one if I'm writing beta is equals to your alpha plus of your alpha into your beta. All beta terms you take on one side 1 minus sorry question mark beta into 1 minus alpha that will be equal to your how much will be your alpha antena e beta common this
Yes.
so beta value will be equal to your alpha divided by 1 minus alpha. If is asking the relation between alpha and beta to identify, so alpha value will be equal to beta divided by 1 plus beta and beta value will be equal to your alpha divided by 1 minus alpha. So in the transistor as of an amplifier we need to remember that input potential is being given by this formula and output potential is given by your collector and emitter. Input is between base and emitter, that is base current into resistance. Output current is between potential between your output is nothing between collector and as well as of your emitter. That means VCE is equals to your change in the collector current into your RL. RL is nothing but load resistance. Okay, very important relations there.
Yes, sir.
Sure. Next one on one more important formula in this one. How do you define voltage gain? Voltage gain. Voltage gain is represented by AV. Formula gurtunda voltage gain will be equal to your output voltage divided by input voltage. This is our formula. Output ekkada vastundi collector ekkada vastundi, so it is output ante this one is output, that is delta VCE divided by input is delta VBE. This one is delta VBE. So that will be equal to how much beta? Minus of your delta IC into your RL divided by delta IB into your RI. Okay. See this one.
Sir.
Collector current divided by base current is known as what beta? IC divided by your IB. Gurtunda?
Yes,
Collector
sir.
current divided by your base current is called as of what? Transconductance. Sorry, it is called as what? IC by your IB is represented by what beta? Beta. Antena? Beta ne
Yes,
kada?
sir.
So AV will be equal to output voltage will be equal to your minus of your beta into your output resistance divided by input resistance. Now see this one. Beta divided by your RI is known as what? Transconductance. Transconductance represented by GM. GM will be equal to beta divided by RI. And voltage gain can also be represented by the formula AV is equals to minus of your GM into your load resistance. దీనిపైన ఈరోజు ప్రాబ్లమ్స్ చేయొసారి కంపల్సరీ తీసి circuit problems. Okay. So
Yes,
that
sir.
one is about your voltage gain. Voltage gain is output voltage by input voltage. Formula is AV is equals to minus of your GM into your RL. GM అంటే ఏంటన్నా transconductance, that is ratio of beta by your RI. Okay. దాని తర్వాత one more and very important term, that is about your power gain. Power gain. Power gain is represented by your AP. So how do you represent power gain? Power gain is equals to your output power divided by your input power. Done? So how do you write the power beta? P is equals to V into I kada. Output ante enti? Delta VCE into your delta of IC divided by input ante delta of your VBB into your delta of your IB. That means output power gain will be equal to your, I can write this output by input is nothing but equal to your AV into your IC by IB will be equal to your beta. So output power will be equal to voltage gain into your current gain. Isn't it?
Yes, sir.
AV can also be written as AV kuda ikkada substitute cheskunte. This can also be written as right now. Power gain is also equal to your, this will become for me how much for me? Power gain can also be written as of your GM into your RL into your beta. Done?
Yes, sir.
Now GM ante enti? Beta by RL. Power gain is also equal to your beta divided by input resistance into output resistance into beta. And this will become for me beta square into your output resistance by input resistance. So power gain inko standard formula vachesi for me is beta square into your RL divided by RI. This will be your AP. Done? Very
Yes,
important
sir.
relations, but these are really very important relations for doing the numericals. Transistors pina compulsory questions vastuntayi. These are basic things you need to remember in your transistor for doing the problems. Output power, input power, voltage gains, isn't it? So these are all very important. Like this part of relation, power gain.
Yes, sir.
Yes. Okay.
Yes, sir.
ఈరోజు నేను పంపించిన దాంట్లో ఏం చేస్తామంటే వాట్ యూ డూ ఇస్ ట్రై టు కంప్లీట్ టుడే ద రివిజన్ ఆఫ్ యువర్ కంప్లీట్ సెమీ కండక్టర్స్ ఒకసారి విత్ లాజిక్ గేట్స్ ఎవ్రీథింగ్. డామ్ షూర్ క్వశ్చన్ అడుగుతున్నాడు. దాని తర్వాత న్యూక్లియర్ ఫిజిక్స్ అయిపోగొట్టుకో, ప్లస్ ఫోటో ఎలక్ట్రిక్ ఎఫెక్ట్ అయిపోగొట్టుకో, డి బ్రోగ్లీ వేవ్ లెన్స్ అయిపోగొట్టుకో, అండ్ దాంతో పాటు కరెంట్ ఎలక్ట్రిసిటీ ఒకసారి అయిపోగొట్టుకో. ఓన్లీ పీవైక్యూస్ చేయి, కరెంట్ ఎలక్ట్రిసిటీ ఒకసారి చేయి. దీంట్లో ఒక 20 క్వశ్చన్స్ చేయి, దీంట్లో ఒక 20 క్వశ్చన్స్ చేయి, కరెంట్ ఎలక్ట్రిసిటీ ఒక 10 క్వశ్చన్స్ చేయి. దాని తర్వాత సౌండ్ వేవ్స్ మార్నింగ్ ఎర్లీ మార్నింగ్ అని లేచి చేయి. సౌండ్ వేవ్స్ పైన ఒక 5 to 10 క్వశ్చన్స్ చేయి. అండ్
సరే పీవైక్యూస్ చాలా కష్టం అవుతుంది సాల్వ్ చేయాలంటే.
చూసుకున్నాను అట్లీస్ట్ బేసికల్ గా అన్ని చేయకు, ఓ 5-6 క్వశ్చన్స్ అయినా కంప్లీట్ గా చేసుకో ఒకసారి.
ఎస్ సార్ 2019-18 చాలా అంటే ట్రిక్కీగా ఉన్నాయి, అర్థమైతే లేదు ఎట్లా ప్రొసీడ్ అవుతాం క్వశ్చన్ తోటి.
ఏది ఈ టాపిక్స్ లోనా?
Yes, sir. Semiconductors are current electricity, no?
అంటే కరెంట్ ఎలక్ట్రిసిటీ కొన్ని క్వశ్చన్స్ తీసుకొని అట్లీస్ట్ బేసిక్స్ ఉన్నాయి కదా నీ దగ్గర ఇప్పుడు
Yes,
కొన్ని
sir.
కరెంట్ ఎలక్ట్రిసిటీ సిరీస్ ప్యారలల్ కాంబినేషన్ లేకపోతే ఫార్ములా బేస్ ఏదో క్వశ్చన్స్ కనిపిస్తాయో అవి తీసుకుని ఒకసారి రఫ్ గా రివైజ్ చేసేసుకో సరిపోతుంది బికాస్ యూ కాంట్ సీ ఇట్ రైట్ నౌ ఫర్ ద డెప్త్ ఆఫ్ ది అనాలిసిస్ ఆఫ్ దిస్ చాప్టర్స్
Yes, sir.
ఓకేనా సో ఏం చేయమంటే ఈ ఒక్క రోజులో రేపు టుమారో యూ కీప్ ద ఫుల్ స్టాప్ ఫర్ దిస్ చాప్టర్స్ ఒకసారి రివిజన్ కి ఎందుకంటే టుమారో
Okay,
ఇస్
sir.
25th సో 25th ఈ టాపిక్ రివిజన్ చేసుకున్నాం అనుకో దెన్ 26th యూ గో ఫర్ యువర్ రివిజన్ ఆఫ్ యువర్ ఫస్ట్ ఇయర్ టాపిక్స్
Yes,
like heat
sir.
and thermodynamics, KTG, thermodynamics, OSAR value, heat transfer, isn't it? SHM,
Yes, sir.
isn't it? Errors, units and dimensions, isn't it? Units and dimensions, work power energy, isn't it? Surface tension, మన చెప్పాను surface tension, elasticity, ఈ చాప్టర్స్ ఒక రోజు మొత్తం రివిజన్ పెట్టుకొని ఫార్ములా బేస్డ్ వస్తాయి ఓన్లీ ఫార్ములా చూసుకో కనీసం 5 to 10 క్వశ్చన్స్ చేసుకుంటే వెళ్ళిపో సరిపోతుంది effectively revision
sir.
27th you can sit for your own revision of complete topics and 28th you can write your exam.
Yes, sir.
Okay na?
Okay, sir.
Take care beta. Bye.
Yes, sir. Bye, sir.